Now we're going to add an arrow to this line, making it an axis, and we're actually going to call this an x-axis. And we're going to let x equal 1 at this point, x equal negative 1 at this point, and 0 in the middle. Okay? Now, if this is 0, this is 1, and this is negative 1, then what are the coordinates of these other positions? Well, this position here, this position looks like it's about halfway between the 0 and the 1, so we're going to call that maybe about 0.5, and this one's on the negative side, so we'll call that negative 0.5. This one looks like it's between 0.8 and 0.9. I'm going to cheat a little bit. I know that this is closer to 0.9 than it is 0.8. So I'm going to label that 0.9. I'm going to label this negative 0.9. It's actually about 0.876, about 2/3 of the way between 0.8 and 0.9. Actually 3/4 of the way. But we see that we have these coordinates that are associated with the 0, 30, 60, 90, 120, 150, and 180 degree positions. Well, when we do this, if we let this be negative 1 and this be positive 1 with 0 in between, then we say that the cosine of 30 degrees appears to be, and I'll write little wavy equal signs, appears to be about 0.5. Sorry, that should be, let's cross that out, and let's write it correctly. Cosine of 30 degrees appears to be about 0.9. Now the cosine of 30 degrees is just the coordinate that you get when you do this. Again, from negative 1 to 1 with 0 in the middle, whatever the coordinate of this is the cosine of 30 degrees. The little wavy equal sign means the cosine of 30 degrees is about equal to 0.9. And similarly, we can see that the cosine of 60 degrees would be what? Well, 60 degrees gives us a coordinate of about 0.5. And, of course, 90 degrees, we end up with a coordinate of 0. And so forth. The cosine of 120 degrees would be negative 0.5. Cosine of 150 degrees would be negative 0.9. Cosine of 180 degrees would be negative 0.1. If we continue at 30 degree increments, now of course we want the 45 degree increments on the other side of the circle, but if we were to continue at 30 degree increments, we would go back through the same numbers in reverse order. So the cosine of 210 degrees would be negative 0.9. Another 40 brings us to 240 degrees. Another 30 brings us to 240 degrees. We'd have negative 0.5, and so forth. And this could continue all the way around the circle until we end up with the cosine of 360 degrees, which would be 1. Now we know that's 1 because we know that this point is the x equals 1 point. There's another way to measure angles. We don't measure angles only in degrees. There are lots of different units in which angles can be measured. Because the circumference of a circle is 2 pi times its radius, we're going to divide the circle into what we call 2 pi radians of angle measure. We're going to say that if we go all the way around the circle, we've gone through an angle of 2 pi radians. Now there are reasons for that, and we're not going to go into those reasons in any depth. Just if we do so, first we notice that 30 degrees goes into 360 degrees how many times? Well, we could count them. 1, 2, 3, 4, 5, 6, and 6 more makes 12. So that 30 degrees is 1/12 of the 360 degree circle. Well, 1/12 of 2 pi radians is 2 pi divided by 12, which is pi divided by 6. So every 30 degrees corresponds to pi over 6 radians. So when we go to 30 degrees, we're at pi over 6 radians. When we're at 60 degrees, we're at twice that, which we're going to say is 2 pi over 6. Yes, I know that reduces. It reduces to pi over 3, but I'm going to write it as 2 pi over 6 just to keep the pattern. Okay, and then when we go another 30 degrees, we're at 3 pi over 6. Another 30 degrees is 4 pi over 6, corresponding to 120 degrees. 5 pi over 6, 6 pi over 6. Now 6 pi over 6 we'll go ahead and reduce. 6 pi over 6 does reduce, of course, to pi. And if we continue the same interval around the rest of the circle, we're going to get 6 more intervals of pi over 6, and we're going to end up at 2 pi here. So 360 degrees, or 2 pi. Now, if we have an angle in degrees, we've got to write the degree. We can't just write 30 for the angle. It's got to be 30 degrees. If our angle is measured in radians, we don't have to write radians because that is the automatic default unit of measure for an angle. A degree is not a standard default unit for an angle. A radian is. So, well, what can we say now? We can say that the cosine of pi over 6, well, pi over 6 is the same as 30 degrees. We can say that the cosine of pi over 6 is what looks to be about 0.5. And the cosine of 2 pi over 6, and I did the same thing here. I'm going to have to cross that out. That's 0.9, not 0.5. Okay. Cosine of 2 pi over 6 is 0.5. I'm just so anxious to get to that 0.5 because I happen to know that's exact and this isn't. We'll see that in a few minutes, etc. Notice how I used dominoes to obliterate my previous error. Don't have a way of inserting a domino in here, so I can't pretend I didn't make that one. Okay, so what we see is that we can divide this circle up into 12 intervals, 12 arcs, 12 equal arcs, each of which is either 30 degrees or pi over 6 radians. We can start numbering them from here and move around counterclockwise. And we can estimate the coordinates of the points that we get if we project straight down, as if we're looking straight down on the circle and making marks on our tabletop or our piece of paper. Again, remember that these marks correspond to the positions of a pendulum at equal intervals as it swings back and forth between one end and the other.